Hello everyone, just confirm whether my voice is audible or not. Am I audible to you? Just confirm me once whether my voice is audible or not. Okay. So a very good evening everyone. Myself Prateek Mishra and I welcome you all to the YouTube platform of IMS Gate Academy. We are conducting this series for excellent practice question which will be very helpful for upcoming GATE examination in the month of February. So this is a session for air pollution and solid waste management. We have discussed important concepts through concept series and now we are discussing important and excellent questions through this series of excellent practice questions expected for GATE 24. So today we will going to see very important questions from air pollution and solid waste management, and I'll ensure this. Whatever concept we will discuss are the concepts which are most frequently asked in your examination. So watch this video till the end and try to figure out what all questions we do in this session. So I'll start my session with this very first question from solid waste management. Okay, so every time I'll pose this question, I'll give you a time for 1 or 2 minutes to solve that question, understand that question, and then we will discuss. So this is a question from solid waste management. You can have 2 minutes of your time. Just go through this question and try to solve it. So this is your 2 minutes timer for this question. Please start doing it. And your time starts now. Okay. So let's solve this question. So this is a question from solid waste management and this question is based on the energy content. Question says that the composition and energy content of a representative solid waste sample are given in the table. If the moisture content of the waste is 26%, the energy content of the solid waste on the dry basis is. Okay. So first of all, my dear students, what is energy content? So if I talk about energy content, it is, so energy content So energy content on discarded basis is equal to summation of weight of the component of the solid waste, which is Pi, multiplied by the energy content of that individual component, that is EI. What is P? P is weight of the component of solid waste, and EI is energy content of that component of that solid waste. So this is your energy content on the discarded basis. For energy content on the dry basis, we require moisture content. So if moisture content is given to us, so if moisture content is mc%, then energy content on dry basis can be calculated as, so energy content on dry basis is equal to energy content on discarded basis multiplied by 100 divided by 100 minus moisture content. So this is the relation you should use for calculating energy content on dry basis. Now, for calculating energy content on dry basis, first of all, I need to calculate energy content on discarded basis. For calculating this, we are given with this table. The food component are given to us, then percentage by mass is given to us. These are not the weights, but it is the percentage composition of individual components. Then you know the energy content on the discarded basis. Energy content on the dry basis you need to calculate in megajoule per kg. Okay, so first of all what you do is you assume total weight of the solid waste as 1 kg. So let us assume total weight of solid waste as 1 kg. Total weight of solid waste is 1 kg. Okay. Now from this we can calculate the weight of individual components. So for components of solid waste, I'll write here. So you have components. So components include food waste, paper waste, cardboard and plastic. So you have food waste, then you have paper waste, then you have cardboard, then you have plastic waste, and then you have other waste. So these are the different components of your solid waste, right? Now the percentage of food waste is 20%. So if total solid waste is 1 kg, 20% of it will be food waste. It means that the weight of component will be, so in the second column, I'll write down weight of components. Weight of components in kgs. So your food waste is 20% of 1 kg, which is 0.2 kgs. Then you have paper waste. Now paper waste is 45% of the total waste. So total waste is 1 kg, so paper waste is 0.45 kgs. Then accordingly I will write down weight of all the components. You have 5, 10 and 20. So this is 0.05 kgs. Then you have 10%. So this is 0.1 kg. And then you have 20%. So this is 0.2 kgs. So now this is the weight of individual components of your solid waste. This is your food waste, this is your paper waste, cardboard, and then you have plastic waste, and then you have other waste. Now along with this, you are also given with the individual energy components. So this is the column of energy component, and energy content on discarded basis in megajoule per kg is given to us. So energy content on discarded basis in megajoule per kg is given to us. So what does this energy content means? It means that by burning 1 kg of the food waste, here you can see, by burning 1 kg of the food waste, 4.5 megajoule of energy is produced, or 4.5 megajoule of energy is produced, right? So this is 4.5, 16, 14. I'll just write down this. So this is 4.5, 16, 14. Then you have 32 and 8. And this is 8. Now this is the energy content in which you are burning 1 kg of this food waste. 1 kg of food waste will produce this much amount of energy. Then burning 0.2 kg of food will produce how much energy? That we need to calculate. So in the last column, we will calculate that. So in this column of energy content on discarded basis, by burning 0.2 kg of food waste, the energy produced is 0.2. It is 0.2 into 4.5. So this you can calculate. Next, burning 0.45 kg of paper waste will produce energy which is equal to 0.45 into 16. Then accordingly, I'll just multiply this column 2 with column 3 to get the individual energy content that are produced by burning this much amount of waste. So this is 0.05 into 14, then 0.1 into 32, then you have 0.2 into 8. So this individual energy component I have calculated. Finally, I have to take the summation of these individual component to take or to get the energy content on discarded basis. So just do this calculation quickly. So I'll do calculation along with you. This is 0.2 into 4.5. So this is 0.9. Then this is 0.45 into 16. So this is 7.2. Then this is 0.05 into 14. So this is 0.7. Then this is 3.2. Then this one is 1.6. Just add up all these things. So this is 1.6 plus 3.2 plus 0.7 plus 7.2 plus 0.9. So this comes out to be 13.6. Now this 13.6 megajoule of energy is released by burning 1 kg of this solid waste. So this is 13.6 megajoule per kg. So this is your energy content on discarded basis. So energy content on discarded basis is 13.6. is 13.6 megajoule per kg. This is your energy content on discarded basis. Now from this you calculate energy content on dry basis. So relation we already know, energy content on dry basis is equal to energy content on discarded basis, which is 13.6 multiplied by 100 divided by 100 minus moisture content. Now moisture content is directly given to us. Moisture content is 26%. So here you substitute 26. You need to substitute in percentage only, right? Because we are using 100. So just do this. So this is 100 divided by 100 minus 26. into 13.6. So it comes out to be 18.38. This is 18.38. Yeah, 18.38 megajoule per kg. So this is our final answer. So this is one of the favorite area from where regular questions we are seeing in solid waste management. So you can just follow this entire mechanism for getting quickly the questions from this energy content. Now, one more thing. Two energy content we have seen, energy content on discarded basis and energy content on dry basis. There is one more energy content which can be asked. So this is your energy content on dry basis, which is energy content on discarded basis into 100 upon 100 minus moisture content. Now if you are given with the percentage ash or ash content, if ash content is known, if ash content is known, that is, this is your percentage ash, right? If this is known to you, then one more energy content you can calculate. That energy content is known as energy content on ash free basis. This is equal to energy content on discarded basis into 100 upon 100 minus moisture content, percentage moisture minus ash content, and everything you need to keep in percentage, right? Because we are using 100. So this formula you can use because a lot of questions again you will see from this. So if I talk about this area or this segment of solid waste management with respect to energy content, three straight formulas are there. First one is energy content on discarded basis. So directly you can calculate summation of Pi into Ei. Second is energy content on dry basis. So you can use this relation for calculating that. And third one is if you know percentage ash, then you can calculate energy content on ash free basis. So these are the prominent areas from where question from energy content for solid waste management can be framed. Okay. Now moving on with this. Let's move to the next question. This is again a question from solid waste management. Take 2 minutes of time and try to solve this. So here is your timer again starting. Please go for this. Okay, so let's see this question. The question says that, this is the question from solid waste management. Question says that a municipal waste handling facility, 30 metric ton mixture of food waste, yard waste, paper waste was available. The moisture content of this mixture was found to be 10%. Okay. Right now, what is the picture I am telling you? 30 metric ton of solid waste is there, which is having the moisture content of 10%. Further, the ideal moisture content for composting this mixture is 50%. The amount of water to be added for this mixture to bring its moisture content to the ideal condition in metric ton is. So again I am repeating this, what the question is saying. Question says that you have 30 metric ton of solid waste, and for this solid waste moisture content is 10%. For composting this solid waste, the moisture content required is 50%. Means MC2% required is 50%. Okay. Now, how much amount of water we should add in this solid waste to increase the moisture content from 10% to 50%? That is a very simple question. I hope you have understood this question. What the question says? 30 metric ton of solid waste is there, which is having a moisture content of 10%. Now we need to increase this moisture content up to 50%. So for increasing that moisture content, how much amount of water you need to add? That is what is asked in the question, right? Now this is the question which use proximate analysis. You require the formula of moisture content. Okay, now let's see this. So when you talk about the solid waste, so solid waste is a mixture of solids plus water. Okay, solid waste is a mixture of solids plus water, right? Now initial weight of initial weight of solid waste is given to us as 30 tons. Okay. And your initial moisture content is now your initial moisture content is 10%. Okay. Now why we will increase this moisture content from 10% to 50%? We will going to increase the weight of water. The weight of solids will be constant. For increasing the moisture content from 10% to 50%, you will going to pour some amount of water, but the weight of solids will remain constant, whether the moisture content is 10% or 50%, right? Now one guess we had that if we increase the moisture content, weight of water will increase, but weight of solids will stay as it is. So if I can calculate this weight of solids, that can help us in calculating the moisture content, in calculating the weight of water when you increase the moisture content. Okay, so let's see this. So initial moisture content is given as 10%. Now as per solid waste management, moisture content is defined as weight of water divided by the total weight of solid waste Now here only student makes mistake. In geotechnical engineering, we define moisture content as weight of water to the weight of solids. But in solid waste management, we define moisture content as weight of water to the total weight, right? Now using this relation, I can calculate weight of water. So initial weight of water is initial weight of water is 10% of weight of solid waste. So what is 10% of weight of solid waste? You can just calculate. This is 0.1 into 30. So 3 tons is your initial weight of water. You know the initial weight of water, you can calculate weight of solids. So weight of solids will be total weight minus weight of water. So weight of solids is equal to total weight of solid waste minus weight of water. So this is equal to 30 minus 3. So weight of solids comes out to be 27 tons. This is your weight of solids, right? Now this we know. Now we have to increase the moisture content up to 50%. And when you increase the moisture content up to 50%, you will add some amount of water, and due to which weight of the solid waste will going to change, right? So after adding water, let the new weight of solid waste be X. Let the new weight of solid waste after adding water be X tons, right? This is the new weight of solid waste. Now for this new weight of solid waste, new moisture content is 50%. New moisture content is 50%. Now from here you can calculate the new weight of water. New weight of water is equal to 50% of X, which is X by 2 tons. This is the new weight of water, right? Now using the new weight of solid waste and new weight of water, you can calculate the weight of solids, right? And that weight of solid is fixed. That weight of solid is constant, which is 27 tons. So I'll write like this. New weight of solid waste is equal to weight of solids, which is constant, weight of solids plus new weight of water So new weight of solid waste is X, weight of solids is constant 27 tons, and new weight of water is X by 2. So from here you can calculate the value of X, which comes out to be 54 tons. This is the new value of X. Now the new weight of water can be calculated, which is X by 2. So new weight of water is X by 2, which is 54 by 2, which comes out to be 27 tons. This is the new weight of water. Now you know the initial weight of water. Initial weight of water is 3 tons. Here you can see. This is the initial weight of water. You know the new weight of water. From that, you can calculate the amount of water added. So amount of water added is equal to the new weight of water minus initial weight of water. So new weight of water is 27 tons and initial weight of water is 3 tons. So our final answer is 24 tons. So the amount of water required to be added in the solid waste to increase the moisture content from 10% to 50% is 24 tons. So again, a very simple questions are framed from solid waste management. They are more kind of aptitude question. So while attempting any question from solid waste, please read it carefully because language will be tricky. But once you understand the language, once you understand the process, it will be very easy to solve such type of questions. Okay, now moving on with this. Let's see another question. Okay, so this is a question from air pollution, and this concept is frequently repeated in your exam. I am giving you 2 minutes, just go through this question and try to solve it. Let's see this question. So this is a question from air pollution. Question says that a sample of air is analyzed at 25 degrees Celsius and 1 atmosphere pressure and is reported to contain 0.04 ppm of SO2. Okay. Atomic mass of sulfur is 32, oxygen is 16 gram per mole. The equivalent SO2 concentration in microgram per meter cube is. So in this question, SO2 is given in ppm and you need to convert this ppm into microgram per meter cube. So this kind of unit conversion questions are frequently asked in your examination. Okay. Now I'll tell you the best way to crack this. You look into this carefully. First of all, what do you understand by 1 ppm? So 1 ppm is 1 part of solute dissolved in 10 raised to power 6 parts of solvent. Okay, so this is the standard definition of ppm that we have read long back. Now here solute is SO2. SO2 is present in air. So SO2 is the solute and solvent is air. It means that one part of SO2 present in 10 raised to power 6 part of air. This is what we mean by 1 ppm of SO2. So 1 ppm of SO2 means one part of SO2 present in 10 raised to power 6 part of air. Now these part can be either in terms of volume or it can be in terms of weight. Okay. In the question, just by observing the unit microgram per meter cube, this meter cube is the volume. So basically this part we want in terms of volume. So I can write this ppm is, so 1 ppm of SO2 means 1 ppm of SO2 means 1 meter cube of SO2 dissolved in 10 raised to power 6 meter cube of air. This is what we mean by 1 ppm of SO2. Okay. Now if anyhow I can get the weight of this 1 meter cube of SO2, I can easily convert ppm into gram per meter cube. Right. So what I am saying is, if anyhow I can calculate the weight, of this quantity, the unit that I will get will be gram per meter cube, right? So this is an easy conversion from ppm to gram per meter cube. Weight is always represented in gram, milligram, microgram, like that. I am just writing grams. So this is the best way to convert ppm to gram per meter cube, right? Now the focus is on calculating the weight of this 1 meter cube of SO2. So let me take you back to the chemistry class of 11th and 12th, where you have studied this ideal gas equation and everything you studied for thermodynamics. Okay. So back then we know that at STP, that is at standard temperature and pressure. What is standard temperature? Standard temperature is 273 Kelvin or 0 degree Celsius. 273 Kelvin or 0 degree Celsius. What is standard pressure? It is 1 atmosphere. It is 1 atmosphere. At standard temperature and pressure, you can mention this as a note point also. At standard temperature and pressure, 1 mole of any gas, 1 mole of any gas, okay, I'll write like this. At STP, at standard temperature and pressure, 1 mole of any gas, 1 mole of any gas occupies 22.4 liters of volume. One mole of any gas occupies 22.4 liters of volume. Let me check whether our condition are STP or not. So this is the question. Temperature is 25 degrees Celsius. What is there for STP? STP is 0 degrees Celsius or 273 Kelvin. Atmosphere is 1 atmosphere. So the gas is not at STP. So first of all, I need to calculate volume of 1 mole of SO2 present at 25 degrees Celsius. Now for calculating that, I will use the ideal gas equation. So by ideal gas equation, right? So PV is equals to nRT is your ideal gas equation. Now when you just rearrange this, you have PV by T equals to nR, and this is N is 1 mole and R is universal gas constant. So this seems to be a constant, right? So we can write down at two conditions, P1 V1 by T1 is equal to P2 V2 by T2. Okay, now let's see how to use this equation for calculating volume of 1 mole of SO2 at 25 degrees Celsius. First of all, at standard temperature and pressure. So pressure is 1 atmosphere. 1 mole of any gas occupies 22.4 liters of volume. and T1 is your standard temperature, which is 273 Kelvin, right? So this is the values for standard temperature and pressure. Now on the other side, I will write down the values which are given to us. So pressure of the gas is 1 atmosphere. V2 I need to calculate, and temperature of the gas is given as 25 degrees Celsius. So I convert this into Kelvin. So this is 273 plus 25. So from this V2 will give us the volume of 1 mole of the gas or 1 mole of SO2 present at 25 degrees Celsius. So calculate this. I'll calculate along with you. So this is 22.4 divided by 273 multiplied by 273 plus 25. So this is 24.45. So V2 comes out to be 24.45 liters. This is your V2. Now what it means is, at 25 degrees Celsius, 1 mole of SO2 occupies 24.45 liters of volume, right? Now what is 1 mole of SO2? Sulfur is 32, oxygen is 16. 16 into 2, 32. So 1 mole of SO2 is 64 grams of SO2 occupies 24.45 liters. Okay. Now I can just write this statement in opposite way. So what I will write is 24.45 liters of SO2 weighs 64 grams. Okay. So what is the weight of 1 liter of SO2? So 1 liter of SO2 weighs 64 divided by 24.45 grams. This is the weight of 1 liter of SO2. Now you can calculate weight of 1 meter cube of SO2. So 1 meter cube of SO2 weighs 64 divided by 24.45 into 1000 grams. Okay. So 1 liter of SO2 is this much. So 1000 liter of SO2 is 64 divided by 24.45 into 1000. And we know that 1000 liter of SO2 means 1 meter cube of SO2, right? So this is the weight of 1 meter cube of SO2. Now again using the relation, so 1 ppm of SO2 means 1 ppm of SO2 means 1 meter cube of SO2 dissolved in 10 raised power 6 meter cube of air, right? We have calculated 1 meter cube of SO2. This is what we have calculated. This is weight of 1 meter cube of SO2. 64 divided by 24.45 into 1000. So this is equal to 64 divided by 24.45 into 1000. So this is grams divided by 10 raised power 6 meter cube, right? So now this is the concentration of 1 ppm of SO2. So this is the concentration of 1 ppm of SO2. In the question, the concentration of SO2 is given as 0.04 ppm. So 1 ppm you know, then you can calculate for 0.04 ppm by multiplying it by that number. So this is 0.04 ppm. So 0.04 0.04 ppm of SO2 is equal to 0.04 into 64 into 1000 divided by 24.45 into 10 raised power 6. Now this is gram per meter cube. This 10 raised power 6 in gram, this will be microgram per meter cube because it is in denominator, and rest you can calculate to get the concentration of 0.04 ppm of SO2 in microgram per meter cube. So just do this. So this is 0.04 into 64 into 1000 divided by 24.45. So this comes out to be 104.7 microgram per meter cube. So this is your concentration of 0.04 ppm of SO2 in microgram per meter cube. Again, a very important concept. Every year we see a question from this concept, not just for the paper in civil engineering, even in the paper for environmental engineering, which you can take up as the second paper for GATE exam. So again, this is a very important concept. If you have any doubt, you can just post it in the chat section, or else we can move ahead. Okay, so this is your question. Let's move ahead with this next question of air pollution. Try this one. Have your 2 minutes. Your time starts now. Just go with this. Okay, let's see this question. The question says that, this is the question from air pollution. Question says that a baghouse filter has to treat 12 meter cube per second of waste gas continuously. So means the discharge of emission is given to us, which is 12 meter cube per second. The baghouse is divided into 5 sections of equal cloth area. Please note this down. The baghouse is divided into 5 sections of equal cloth area such that one section can be shut down for cleaning and repairing while the other 4 sections continue to be operate. Means out of 5 sections of this baghouse filter, 4 sections are operational. 4 sections are operational. And these 4 sections are responsible for treating this much amount of emission, that is 12 meter cube per second of emission is treated by these 4 sections, right? Now one more data is given to us. The area to cloth ratio of 6.0 meter cube per minute per meter square will provide sufficient treatment to the gas. Okay. Now for air pollution and solid waste management, again I am saying this. Questions framed will be easy, but their language will be twisting, or their language will be twisted, right? Now just observe this, area to cloth ratio. Area to cloth ratio is nothing but how much amount of cloth area is required to treat the discharge, right? So area to cloth ratio is 6 meter cube per minute per meter square. Let's crack this first. So area to cloth ratio is, sorry, not area, air to cloth ratio. Air to cloth ratio is 6 meter cube per minute per meter square. What it means, right? If you can crack this, your question is solved. Air to cloth ratio means for treating 6 meter cube per minute of air, for treating 6 meter cube per minute of air or discharge, air or emission discharge, you require 1 meter square of cloth area. Again I am saying this, for treating 6 meter cube per minute of emissions. For treating 6 meter cube per minute of emissions, 1 meter square of cloth area is required. 1 meter square of cloth area is required. Now how much amount of emission we need to deal? We need to deal with 12 meter cube per second of emission. So emission is given to us as 12 meter cube per second. Okay. From here I can calculate the total amount of cloth area which is required to treat this emission. So total cloth area required to treat, total cloth area required to treat 12 meter cube per second of emission is equal to emissions 12 meter cube per second. Now I have to convert this second into minute because here it is in minutes. So I'll multiply it by 60. Now divided by the rate, air to cloth ratio. So this is 6. So this is the total amount of area in meter square required to treat 12 meter cube per second of emission. Calculate this. So this is 2 times. So this comes out to be how much? So this is like 120 meter square. So this is the total cloth area required, right? Now further we will read the question. The individual bags are 32 centimeter in diameter and 5 meter in length. The total number of bags in integer required in the bag house is, right? So you are given with the individual dimensions of the bag. So individual dimension is 32 centimeter and 5 meters. These are the individual dimensions of the bag. Number of operational bag house filters are 4. But total number of bag house filters are 5. So first thing that I want to tell you is, or first thing that I want to discuss or calculate here is, how many bag house or how many individual bags are present in each section. 4 operational sections I have. So first thing, based on this total cloth area, I need to calculate how many bags are present in individual sections, right? For doing that, I will first calculate, so cloth area of individual bag. Cloth area of individual bag is, now the bag looks like a cylinder. This is your bag. The diameter of the bag is given as 32 centimeters and height is given as 5 meters. This is your individual dimensions of the bag, 32 centimeter and 5 meter in length. Okay, so this is your individual bag. Now for calculating the area of this is pi into d. D is 32 centimeters, so 32 by 100 into 5. So this is the individual area. So this is pi into 0.32 into 5. So this comes out to be 5.026 meters square. This is your individual area of bag. Now number of bags is equal to, or number of bags required to treat 12 meter cube per second of emission is equal to total cloth area, which is 120 meter square, divided by area of each bag, which is 5.026. This is area of each bag. So this is 120 divided by 5.026. So this is 23.87 number of bags. So let us approximate into 24 bags. So these are the 24 bags required to treat this much emissions. So these 24 bags are well placed in 4 sections. 24 bags are placed in 4 sections. So number of bags in each section is equal to So this is 24 by 4. So 6 number of bags are present in each section. Now total, there are like 5 sections present in your baghouse filters. So total of 5 sections present. So total number of bags in 5 sections is equal to 6 into 5, which comes out to be 30 bags. So these are your total number of bags which are present in your 5 sections. Now in the question, what is asked? So the total number of bags in integer required in the baghouse filter is, so again the total number of bags required are 50. This we have already calculated. This is our final answer. Total number of bags required are, sorry, not 50, 30. Total number of bags required are 30 in your baghouse filter, right? So again, this kind of easy question, again you can see just entire method, there is nothing like any formula is required. If you understand the language, you can crack the question very easily. Okay, chalo, moving on to the next question. Just try this one. Try this one. Okay, let's see this question. This is the question from air pollution. Question says that a coal containing 2% sulfur is burnt completely to ash in a brick kiln at a rate of 30 kg per minute. Means you are given with the rate of coal burning, that is 30 kg per minute, and in that coal 2% is your sulfur content. Now, the sulfur content in the ash was found to be 6% of the initial amount of sulfur present in the coal. It means that whatever sulfur is present in your coal, out of that sulfur, 6% of the sulfur is present in the ash. The molecular weight of sulfur, hydrogen and oxygen are 32, 1 and 16 gram per mole respectively. The annual rate of SO2 emission from the kiln in tons per year is. Now again, this is a question more of an aptitude based. What is given to you is coal you are burning in a kiln, right? And in that coal, sulfur is present. You are burning coal and the rate of burning coal is 30 kg per minute. This is the rate at which you are burning coal. In this coal, 2% is sulfur present. 2% is sulfur. Okay. Now, out of this sulfur which is present in the coal, 6% of it is present in ash. So this is the link given to you. You know how much amount of coal you are burning. In that coal, 2% is sulfur. Out of this sulfur present in the coal, 6% is present in ash. Okay. Now you are asked to calculate the annual SO2 emission. So first of all, whatever things we know, that we calculate, and then we will deal with this, how to come to this conclusion. So first thing is, the first thing that I will calculate is how much amount of coal we are burning in 1 year. So total amount of coal burnt in 1 year is coal burnt in 1 year is equal to 30 kg per minute. So this is 30 kg per minute. 1 hour has 60 minutes. Then 1 day has 24 hours. Then 1 year has 365 days. So this is the total amount of coal burnt in 1 year in kgs. So first calculate this. So this is 30 into 60 into 24 into 365. So this is 30 into 60 into 24 into 365. So this is 15,786,000 kgs. So this is the total amount of coal that we are burning in 1 year. Out of this total coal burnt, 2% is the sulfur content. So next is sulfur present in coal is 2% of total coal burnt. So 2% of this value is the total sulfur present in that coal. So 2% of 15,786,000. So this will come out in kgs. So calculate this. So answer into 0.02. So this comes out to be 315,360 kgs. So now this much amount of sulfur you are burning in 1 year. out of this much amount of sulfur, 6% is present in the ash. So sulfur present in the ash is equal to sulfur present in ash is 6% of this value. So this is 0.06 into 315360. So 6% of this value is the sulfur present in the ash. So answer into 0.06. So this comes out to be 18921. This is 18921.6 kgs. So this much amount of sulfur is present in the ash. The remaining sulfur is burnt and present in the emissions. So sulfur sulfur burnt is equal to total sulfur, which is 315360 minus sulfur present in the ash, which is 18921.6. So this much amount of sulfur is burnt. So 315360 minus your, so this comes out to be 29643. This is 29643 8.4. This much amount of sulfur is burnt, right? Now when sulfur burns or when sulfur oxidizes, it combines with oxygen to form SO2. Okay, so from here I can write 1 mole of sulfur burnt produces 1 mole of SO2. Produces 1 mole of SO2. Now sulfur is 32 grams, 32 grams, sulfur is 32 grams. So I can write here 32 grams of sulfur produces 1 mole of SO2 molecule. So oxygen is 16, sulfur is 32. So when you take the sum, you have 64 grams of SO2. So 32 grams of sulfur is producing 64 grams of SO2. So this much amount of sulfur will produce how much amount of SO2 that we need to calculate. So this is 296,438. So this is 296,438.4 kgs of sulfur produces 64 by 32 into 2964. This is 296,438.4 kgs of SO2. So this comes out to be 592,876.8 kgs of SO2 emissions, right? And this is what asked in the question, but in tons it is asked. So in tons, if you need to calculate, so this is 592.876 tons of SO2 emission. This much amount of SO2 in tons will be produced by burning coal at that rate, and this is asked in the question. So again you can see it is a more of aptitude question. Nothing like very important formula or some kind of trick is used. Only you have to read the question properly, understand what is the data given to you, and then you can very easily solve the question. So my dear students, if I talk about air pollution and solid waste management, you can expect a very easy question, but the language will be twisted. So before attempting the question, please read the question twice or thrice, understand it properly, and I am sure you can manage it very easily. So this is all what I have to offer from today's session. Thank you so much for watching patiently. Please join our Telegram group. The link is given in the description box for daily quizzes and important updates regarding to GATE exam and the other technical exams as well. Please register to our zero fee program. It gives us you the content without charging a single fee so that you can have a taste how to prepare for the competitive exam. So thank you so much for listening patiently. Please like and subscribe the IMS GATE Academy platform. Thank you so much.